Hi there and welcome. In this video, we will explore how we can create custom ResultSet methods. Before we start, let's quickly discuss why we might want to consider creating custom ResultSet methods. From personal experience, you will quickly find yourself using the same search and/or filters in various places in your application. For example, you will probably want to filter on account ID, on multiple tables, search for records between dates, so on and so on. Now the problem is that you will end up writing the same DB conditions all over your codebase, which is not great for maintainability. And what if you decide to change or remove columns? You will potentially need to update various places in your code where the column is being used. This is where the custom ResultSet methods are an excellent solution, as they allow us to abstract filter and lookup conditions behind the method names. Okay, enough talking. Let's see how this works in practice. Now, very similar as we did for the result methods, we just need to access the ResultSet class to add a custom method. Now, previously, when we added method in the node result, we already had these node classes generated for us. Now, the difference here is that DBIx does not generate ResultSet classes, so we will need to do this by hand. However, it's very trivial. Now, the first things first, if you don't have this ResultSet folder on your My App level, which is on the same level as the result folder, just create that folder here. And after that, let's say we want to introduce custom ResultSet methods for our node ResultSet. Now to do that, you create a file with the same name as your result, so it's going to be node.pm, and then you type your package name, which is going to be package, schema, my app, result, set, and then the node, which is our package name, return truthy value, and then it's very important that you use parent class, which is going to be DBIx, class, result, set. So basically we're saying that this custom ResultSet class should inherit all the methods from the DBIx class ResultSet. And after that, we can use strict and use warnings. That's just good practice. And now we can write a custom method we want to implement. We want to add a method that returns all the nodes based on importance. So when we access a ResultSet, we want to say, return me only those nodes where important matches the value that we provide. So we can do sub by node importance. You can choose whatever method name you prefer. Now here, the first value is going to be the self context, and self context is going to be the current ResultSet you're going to call that method on. In this case, this is going to be our node ResultSet. And the second value are all the arguments, well, or should I say all the values after self are going to be arguments that you provide to this method. And we get it from the arguments list. Now the next thing, a good practice, is to get an alias of the current table we're accessing. So we have looked before at the alias, where DBIx aliases the current table that it's accessing. For example, if you call the ResultSet method and then you call the all method, you're going to notice in the SQL that your table is aliased with me, or when you're joining tables, it's going to alias the table name. So this is the alias that we currently have set on your ResultSet. We know that we can change the aliases, so it's good to always get the current alias as it is provided. So source alias. And now what we want to return is the ResultSet chained with the lookup conditions you want to provide. So we know the self is a current ResultSet, so all we can do, we can chain search ResultSet, and here the first argument are the where filters. So we can say that we would like to access the alias dot importance, and we would like to get all the nodes where importance equals to the value that we provided to the by node importance method. Now, if we copy the method name, and let's go back to the script, and let's make sure this actually works as expected. So we can do my nodes equals schema. We call the ResultSet, and we're going to access the node ResultSet. And here we're just going to call that method we just introduced, and let's provide a value such as 2. So basically we're saying, return me all the nodes from this node's ResultSet, where the importance, as we introduced, equals a value of 2. So if we go back, and here we want to get all the node results, and just to make sure that it's working as expected, we can say current context importance for all the nodes items we just half-edged. All right, so if we just run this, and here we can see that now we are selecting everything from the nodes table where the importance equals 2. Now, how cool is that? You can introduce your custom methods, and you're not limited to only having a single method here. You can add as many methods as you would like to. For example, we could copy this and introduce a new method that also searches the nodes based on description. Let's call it something like by description underscore like. Here, instead of importance, we want to set this to description. So description, and the alias, we leave it as it is. And now, instead of just saying where the importance equals specific value, we can say something like description, and here we would like to use the like filter, so minus like, and now we want to quote the value we provided between 2 percentage signs, and we would like to escape this, and we do that through curly brackets and importance, right? So all we're doing here, we're just escaping the importance variable, because if you remove these curly brackets, you're going to see that since we're using double quotes, Perl is going to think that we're trying to dereference a hash ref, which is not really the case. So how you can escape the variables, you can just wrap them around curly brackets, or alternatively, just to make this simpler, you can also use this as percentage sign concatenated with importance dot and another percentage sign. Alright, so now this method is accepting description, where it's going to apply it to the like filter in the SQL, and it's going to return all the nodes where description equals the pattern that's given. So if we go back to the script, we now also can chain this method. We just go introduced and provide the strings such as node, save this, and rerun the script. Whoops, looks like there is a syntax error somewhere. It says importance requires explicit package name. Right, so we left importance here, apologies, so this should be description. We save this, rerun the script. We're going to see now that we are looking for description like and the importance. And the cool thing is that you can add as many methods as you like, and you can add all the filter conditions, join conditions, and all the combinations as you can imagine in these abstracted methods, and chain this as many times as you like. You can also call the same methods multiple times. So DBIx is going to be smart enough to apply the condition twice. It's not just going to call the method once and apply, for example, description search just once. So you can also say something like testing, and if we rerun this, we're going to see that there's now add the description like the second pattern, which is our node, and testing, and then it's our importance value. So honestly, the possibilities here are limitless, and these are very, very, very simple examples. You can do or conditions and conditions, and separate these in isolated method names. Now, one final thing is that what if you wanted to add ResultSet methods that apply to all of your result sets, not just the nodes? So now we introduce ResultSet methods which are relevant to only node. So for example, if we wanted to access the user result set and call something like by node importance, if we run this, this is of course going to fail because there is no by node importance. There can be scenarios, for example, you would like a global method on all the result sets that introduce a pagination. Now, how can we do that? Well, one possibility, of course, is that you copy-paste the same method all across the result sets, but much better alternative is that you introduce a base result set from which all the result sets are going to be inherited. And again, that's super easy to do. There's a little bit more thing that we need to do, but it's literally just 2 extra lines. Now, to introduce the base result set, you want to go to your main schema class, which in our case is called myApp, and you want to load a namespace which is relevant to your custom result set. Now here you're going to see a similar warning as we saw on result classes, where it says do not modify anything above this line. So don't do that. Don't modify anything there. But after that, if we just remove that comment that says you can replace everything that's here, copy the package, load namespace, paste it down here, and here what we would like to do, we want to provide additional argument. Default result set underscore class, and here we can add our custom class, which is going to be schema, my app, and result set. Now the next thing, we want to introduce this default result set class, and where you need to add it is the same path as we have the file name. So we know we need to go into schema, my app, and there under my app we want to have this result set class. So go to your my app folder and create a new file and call this result set.pm, and as before we want to create a package which is schema my app result set, return a true t value at the end. And here, very important is that you use parent, which is going to be called DBIx class result set. After that, you can use strict, use warnings, just common practice, and that's about it. You can start introducing your custom global result methods here. Now let's say, as the previous example, we want to introduce a global method which just simply paginates results. So we can do sub, let's call this paginate, and here as before, we're going to get the current ResultSet context, and the values that we expect can be rows, page, and we're going to get that from the arguments list, and we're going to return self, on which we call search ResultSet method. And the first argument is the filter parameter. So actually the first one we don't want to provide because we don't want to filter on anything, but we want to provide the second argument, which is accepting the rows. So rows and the page, which is going to be provided through the arguments list. All right, so if we copy this method, now let's go to the script and let's try to call this. So instead of this method, we can say paginate. And let's see, its first one is the rows. So let's say we want to get 3 rows from the page 2. And if we rerun the script now, we're going to see that our limit conditions are applied, but yes, we actually changed the name from user. We changed the name from node to user. So let's change this back to node because there is no importance on the user result. Let's rerun this. So I quickly had to stop the video just to look at what exactly is the issue here and why we are not getting the paginate method available from our global result set. And the solution is quite simple. We have to remember that we introduced a custom result set for the node. And in that custom node result set, we're using the DB class result set as a parent. Now, when you have a custom result set for specific results, instead of using the DB class result set, you want to use the global custom schema myapp result set, or whatever is your schema structure. So let's copy the name of our custom global result set, and in the node result set, instead of using the DB class result set, we just want to use our custom result set. And now we should have available the paginate methods in all of our result sets as long as we're using the parent class as our custom result set that we introduced. Right, so if we go back to the script and we're accessing nodes, we're trying to call the paginate method. So here, instead of username, we're going to have the importance. Let's save that, rerun the script. We're going to see that now everything's working as expected. We have the paginate method available to us from the global result set that we introduced, which is here. And if we also try to call this on the user result set, save this, and instead of actually using importance, we don't have that on the user result set. We want to use username, save that, rerun the script. We're going to see that now the paginate method works as expected. And as before, you're not limited to using just one method here. You can add as many common methods as you want. For example, if you want to introduce joins or grouping conditions, it makes sense to add these in a global custom result set, and then just make sure that every single custom result set that you add inherits from your custom result set class instead of the DB class result set. That's just a small gotcha. And of course, as we previously saw, we were calling the paginate method on a user. As you can see here, under the result sets, the custom ones that we don't have a user. So DBIx was smart enough to use our custom result set by default for all the result classes that do not have a custom result set defined. Alright, so that's it for this video. We looked at how we can introduce custom result set methods for specific results, and we also looked at how we can introduce a global result set class where you can create methods that are going to be inherited by all the result sets by default. And again, just a reminder, if you have a custom result set classes, just make sure that you use the parent as your custom result set name instead of using the DB class result set. I hope you found this video useful, and I'll see you at the next one.